We're going to look at 6.4, solving trig equations. Here's an example. We have 2 times sine x equals 1. Our goal is to solve for x. First step is to isolate the trig function. In the example, we want to divide both sides by 2. That gets sine x by itself on the left equal to 1/2. Now we want to ask ourselves what angle x has sine of 1/2. Because it's sine and because 1/2 is positive, we are looking for angles in quadrant 1 and quadrant 2. Also because it's sine, we are looking for associated points to angles that have y coordinate of 1/2. Those are the angles pi over 6 and 5 pi over 6. So we get x equals pi over 6 and x equals 5 pi over 6. Those are just 2 of the actual infinite number of solutions for x. Every angle that has the coterminal side shared with pi over 6 is going to have sine of 1/2 and will be a solution, will be an angle measure that's a solution. So we think about this angle that we take pi over 6 and add 1 full rotation of 2 pi, right? We could also take another rotation, which would be adding 4 pi, and we could continue that on adding rotations and ending up with that same terminal side, which has that same point, which is going to give us that same sine value of 1/2. To represent every angle with that terminal side shared with pi over 6, we are going to add n times 2 pi, where n is an integer. And we can do the same for 5 pi over 6. We want to include every angle that shares that terminal side of 5 pi over 6, so we add a multiple of n times 2 pi. Let's solve this equation for x. First, we want to get that trig function by itself. Divide both sides by -2. We have a negative cosine. That is going to give us an angle in quadrant 2 and quadrant 3. So the angles that have cosine of negative square root 3 over 2, the angles that have x coordinate of negative square root 3 over 2, or 5 pi over 6 and 7 pi over 6. Those are 2 solutions, and to include every solution, we want to add n multiples of full rotations, 2 pi. So we add n times 2 pi to each of those angle measures. Let's solve -4 tangent x equals 4. Again, we're wanting to get tangent x by itself, the trig function by itself. Divide both sides by -4, we get tangent x equals -1. Tangent is negative in the second quadrant and the fourth quadrant. And because tangent is y over x for the associated point of the angle on the unit circle, and we've got -1, we are looking for angles that have the same x and the same y coordinate, except for one being negative and one being positive. Those are the angles 3 pi over 4 and 7 pi over 4. So notice that the difference between these 2 angles is pi, or just 1/2 of a rotation with that angle measure of pi. So instead of having to add a full rotation to each of these angles to get to another angle with the same terminal side and the same ratio to give us tangent x equals -1, we just need to add multiples of pi. So plus n pi, and that actually takes care of every angle measure that has tangent of -1. This has to do with the fact that the period of the tangent function is equal to pi, and the period of sine and cosine is 2 pi. So I just referenced back to the work that we did with graphs of trig functions last time, where we defined the period to be the length of the interval over which the pattern in the graph repeats. Let's look at this one, 3 secant x equals 6. So start off with, we want to get the trig function by itself. So we need to divide both sides by 3. We get secant x equals 6 divided by 3, which is 2. Let's remember that secant x is the reciprocal of cosine x. So if we take the reciprocal of both sides here, we can write this as cosine x equals 1/2. We have cosine x equals 1/2. So which angles have a positive cosine value? Those are going to be angles in quadrant 1 and quadrant 4. The angles are pi over 3 and 5 pi over 3. Those each have an x-coordinate of 1/2, so the cosine of those angles is 1/2. X equals pi over 3 and x equals 5 pi over 3. And we're back to having a trig function that has a period of 2 pi. So to get every angle x that has cosine of 1/2, we need to add multiples of that period of 2 pi. So we add n times 2 pi to both those angle measures. 2 minus sine x equals 2. Getting sine x by itself, we first subtract 2 from both sides. So we get negative sine x equals 0. And then divide both sides or multiply both sides by negative 1. We get sine x equals 0. So we want to identify the angles in the unit circle that have sine of 0. So that's going to be y value of the associated point on the unit circle that's equal to 0. So those are the angles 0 and pi. We get x equals 0, x equals pi. Another solution is x equals 2 pi. And we could keep that going, seeing that there is going to be an angle that gives us sine of 0 for every additional pi that we add to the previous angle. We can simplify the solution by writing x equals n pi.